My name is Raoul Empey. I've been moderating all day in this sustainability workshop. We were missing one last presentation by Pro Air Systems. Unfortunately, David McHugh decided not to present. So I'm going to speak about life cycle assessment and using that to evaluate the sustainability credentials of building projects. Okay, I am the principal of Sustaineo and I come from an engineering background. So to begin with, I'm going to introduce some terminology in life cycle assessment, and then we'll look at a pilot project called the NICE project, and I'll conclude with some thoughts and opportunities. So, life cycle assessment is regarded as the most comprehensive environmental tool for assessing the environmental footprint of projects. So you consider each life stage in turn. So from the extraction of materials from the Earth's crust, you then make building products. They have to be transported to site. These are then assembled, and at some point someone will move into the building, live in it and use energy and create emissions. Ultimately the building will come to its end of life. It might be refurbished or it might be demolished. So what happens to those parts? Other terminology might come across. Cradle to gate is simply assessing the environmental impact from the raw material extraction from the ground as far as the factory gate. Cradle to site includes all the impacts up to bringing the materials to site and assembling them. And cradle to grave is when the building is ultimately reaching its end of life. Within EU legislation, there's a big focus on energy efficiency. So you have the building energy rating is a design assessment of the energy efficiency of the building. So that's the operation of the building, the lighting, the heating, the cooling, the power that is all used to run a building. If you look at the carbon footprint, that particular life phase constitutes the carbon footprint. All the other life cycle stages comprise embodied impacts. So how much are these embodied impacts, and do they vary from building to building? Well, let's look at this pilot project. So the NICE project stands for Natural, Energy Efficient and Sustainable Project. It was funded by the Northern Periphery Fund, and the client was the South Kerry Development Partnership, and the pilot project was based in Cloyne, County Cork. It involved the renovation of an existing cottage and the extension out the back. There were 6 particular building practices that the client, which was the Cork Centre of Architectural Education, in conjunction with the South Kerry Development Partnership, they wanted to evaluate what they considered 6 best practices. They were timber frame construction, hempcrete, which is an external insulation applied to a building, consists of hemp fibres, lime and some ordinary Portland cement in this particular case. There are different mixes of hempcrete, but that's what went into this mix. Cellulose insulation is made from recycled newspapers and cardboard, treated with a fire retardant, and that can be blown into the cavities of the wall and the ceiling and the floors to insulate the material. Triple glazed wooden framed windows, a sedum green roof, and a gravel reed bed to treat the wastewater coming out of the house. I guess the continuity between these 6 practices is that they involved local, well, maybe not so local, but renewable and recyclable materials. So a strong focus on wood-based materials. These were the objectives that we were asked to evaluate. So to look at the embodied impacts of mass, energy, and global warming potential, or CO2 emissions. And we were asked to do this on a 100-year life cycle basis. There's some other aspects as well in the tender. Our evaluation team consisted of myself doing the life cycle assessment, and I had input from 2 architects. Fergal McGurl did the U-value calculations and the BER, and Joseph Little looked at health, biodiversity, and hazardous impacts of the various building materials. So where do you start when you're trying to evaluate a building holistically like this, looking at extraction of materials from the ground to its ultimate demolition? How do you go about that? Well, we had a design, the NICE design. So we had an architect's tender package, tender drawings and a specification. And they asked us to compare this to what would normally be built in rural Ireland. But what's a conventional build? Because they didn't provide us with drawings or specifications for this. We considered that a conventional build must have exactly the same architectural form and the same energy performance as the Nice equivalent, i.e. the floors, walls and roof would have the same U values, but that the materials used in the conventional build are those that we normally find. And this is what we came up with. So on the left-hand side we have the Nice design as it was specified by the architect, and the right-hand side is our conventional design based on U values equivalent. So if you look at the second one down, say, the walls of the extension, you see a conventional design might have a blockwork cavity wall. The unusual dimension of a 250 mm cavity with expanded polystyrene, that's just to get the same U value as the timber framed walls with full fill cellulose insulation. After we've agreed what the conventional design was and what we were comparing against, we had to draw up a list of assumptions. What were the embodied emission and embodied energy factors to use against all the materials that go into a building? And doing a 100-year life cycle assessment, there'll be a time when building parts need replacement. So we just assumed conservatively that at the end of a particular building part's lifespan, we would replace 20% of it rather than 100%, which seemed a bit overkill. So typically maybe a slated roof might have a 25-year lifespan. After that you would replace 20%. It might sound over the kill because slate roofs can last 100, 150 years, but it didn't really matter in any sense because we're comparing the Nice design and the conventional design on exactly the same basis. And then we collated data. So it really stems to a mass analysis of the two building designs, going through each and every product and material that went into the building, working out the kilograms, and then converting that to embodied energy, embodied carbon. This is a picture of the cottage here, so before it was touched. It was a Parnell cottage, so about 100 years old, and it had a G rating. After the Nice design, the energy rating was improved to D1 rating. You might be saying that's not very energy efficient, and I would tend to agree. If you're going to call something energy efficient, it has to do better than a D1 rating. But that's what happened, and it was largely due to the building and its new extension having a large window to floor area, a large external surface area to floor ratio, and the architect also hadn't specified heating controls or the efficiency of the wood stove. But a D1 rating still represents a 70% improvement in primary energy consumption, and also because they were using a wood burning stove, the CO2 emissions came down by 93%. So that's looking at the building and the operation. The bottom picture there, you can see the Parnell cottage to the front. They've just applied the hempcrete insulation, which is about 250 mm thick. So you can imagine thick stone walls with hempcrete insulation. You're getting pretty thick walls that are a couple of feet thick. And then out the back, you've got the timber framed extension, which is being clad in western red cedar shingles. Here's a sort of overview of the 100-year life cycle comparison. So you can see on the leftmost column, you've got all the life cycle phases, going from cradle to gate emissions, then looking at operation, transport site, all that. And then the columns are divided into mass. EE stands for embodied energy, EC for embodied carbon. And we've got three types of carbon we consider in this analysis because it was heavily wood-based. So emissions arise from burning fossil fuels, but emissions also rise from the combustion of biomass. And when you're making timber, it's kiln dried. Often you will burn wood shavings or chippings to contribute to the kiln drying process. So is that biomass counted in your emissions or not? Depends whether the timber is treated as sustainably or not. So we just calculated those separately, and you can draw your own conclusions. And the third type of carbon is sequestered or stored carbon. So it's often a strong argument for the timber industry. Our building products store carbon, we lock it in, therefore it's a good thing. Now, will that timber products survive 100 years? It's a big question. When we're doing carbon footprinting, we want to be sure that we can lock away carbon emissions for 100 years to combat global warming. And just to pull out a couple of numbers out of that, you can see that the Nice design was a third of the mass of the conventional design. That's as expected. It's timber frame versus mass concrete trench foundations, and blockwork walls. The embodied energy only, looking at the building holistically, was only an 8% saving. So some building products save more embodied energy than others. But as a whole, it only saved 8%. You might go, why is that when we've saved 64% on mass? The reason largely stems to timber, which has a high embodied energy factor, according to some assumptions built into the calculation. Another thing to note is that both the emissions and the embodied energy resulting from transportation were a lot higher in the Nice design. That is because some of the materials came from further afield. The hemp was shipped over from France, the lime came from Germany, and a lot of the sedum green roof products also came from Germany. I'd like to welcome the gentleman in the back. Thank you for joining today. It's very good to have you. I've got an audience of 2. Okay. Oh yeah, and I've just pulled up just that last speech bubble on embodied carbon for fossil fuels. So it shows a 19% saving. That's if you count the biomass emissions as being carbon neutral. If you don't, the emission savings of the entire building was only 1.4%. So not that terribly exciting. And here's the 2 designs, Nice's versus conventional, looking at the whole life carbon footprint. Broadly, 70% of that carbon footprint over the 100 years would go from operating the building, living in it, and the other 30% is embodied emission. Now you might ask, well, forecasting the future of a building over 100 years is, anyone's guess. So we have an alternative way of analysing the building. And that alternative is called carbon profiling, from a RICS research report published in 2010. And Sustaineo, we developed this profiling technique to look at other environmental hotspots within the building. In this, we're including most of the stuff we did in the LCA, which is the cradle to gate site impacts, and the BER. We're excluding the unknowns in the future. That's the maintenance repair schedule. And we're excluding end of life and demolition because we don't know when the building is going to be taken down in the future. This is what a mass profile looks like. So on the horizontal axis, you have the lifespan, and there's different blocks of color. They represent substructure, floor, external walls, internal walls, floor and ceiling, and then the wastewater treatment package. Each block of color represents a mass footprint. So the lifespan of each element of the building is on the horizontal axis, and then the vertical axis expresses the mass environmental footprint in kilograms of building per square meter of building per year. So the building had a floor area of 80 square meters, a small building. We can do the same thing for embodied energy. So you can see the vertical axis has exactly the same units as a building energy rating. So the building energy rating is shown in pink as primary energy, and then the embodied impact is at the top, again for the different building parts. And again, if you look at the embodied energy, it actually looks kind of similar between the 2 designs. So even though we've used all these natural and sustainable materials, have we reduced our embodied energy footprint? Not so much, perhaps. It's between 22 and 24% of the entire energy footprint. The BER for both designs is the same. That was our assumption, that the building energy performance should be the same. D1 rating. And lastly, here's our carbon profile. So this develops on the previous 2 environmental profiles, but we include the vertical axis in the negative direction to show carbon storage, the amount of carbon stored in wood. And that's sort of grayed out. So you can see on the Nice design, the area of colours for embodied carbon is roughly the same as carbon storage. So there's an argument there to say that by using timber and all these wood-based products, we're making the embodied footprint carbon neutral. We still have the emissions running from the operation of the building. They're very low because we have a wood-based stove, so they're primarily due to energy or electricity from the grid. But again, that's quite small. So we're getting close to a carbon neutral building. On the right-hand side, the conventional carbon profile has a smaller carbon storage element, and that's primarily due to having a cut timber roof. There's a bit of timber in that. Okay. So I guess when you're thinking of near zero energy buildings and near zero carbon buildings, when we get there, when we've got net zero bills and we're generating as much energy on site as we use in the house, then the focus has to shift to the building envelope and all the bits that go in, because each of those building products has an environmental impact. And that's what this analysis is trying to consider. So we looked at the LCA methodology. This different methodology carbon profile shows the embodied carbon to be about around half of the sort of life cycle, well, of the carbon profile. And sequestration or storage is roughly equivalent to that, whereas the convention only had 17% carbon storage. Okay. So looking at the building in its entirety, we have some conclusions on each of the 6 NICE best practices, but I've just drawn the top line here, looking at the building at its whole. It was a third in the mass, and it saved a little bit of embodied energy, and arguably a little bit in carbon emissions. If the architect had specified that timber was procured sustainably, we could have increased the emission savings up to 19%. And if we include carbon storage, then the savings go massive. They go into like 185%. So people often ask, what is the proportion of embodied carbon? Well, looking at it with the 100-year life cycle assessment, it was about 21 to 24%. And you probably heard figures quoted earlier today of about 25–30% being the embodied carbon of a building. But looking at the carbon profile methodology, which gives a snapshot of a building asset in the present, you can see that the embodied carbon looks more like 53 to 54%. So we're ignoring that ultimate demolition, we're ignoring the maintenance and all the additional materials that are going to be needed to keep a building life for a 100-year period. What do all these numbers mean? I like to think of 1 ton of mass being equivalent to a Suzuki Swift. Those 8% embodied energy savings was about 49 gigajoules. What's that? Probably about 2 years of motoring in that Suzuki Swift. And what's a ton of carbon dioxide? The best visualization I saw of this was in Copenhagen in 2009 at the climate talks. They had this big balloon on the street. It occupies roughly the volume of a 3-bedroom house. I think when you think of we emit a ton of CO2, I think that's a great visualization. Some people have concerns over life cycle assessment. I've just probably highlighted a few of them. Future predictions of the life of a building are anyone's guess. Yes, I agree. So that's why we use the carbon profile methodology, as it looks at a building in its present. Embodied energy and carbon calculations are complex and too difficult to model. Yeah, of course they are, I agree. But so too is modeling a building in operation, and we do that anyway. Architects are doing that. They're doing their SBEM calculations and BER analyses and all that. So why can't we do the embodied part in the same way? I argue that we can, and the technology is there and the know-how is there. And then a last quibble with sort of life cycle assessment and doing this sort of analysis might be that, okay, in our analysis we used a generic database, which was the inventory of carbon and energy developed by the University of Bath. And yes, okay, it's questionable, but it's the best we've got at the moment. We did ring up all the manufacturers involved in the NICE design. None of them had environmental product declarations. It's equally hard to get them out of conventional manufacturers. To my mind, I know of 5 manufacturers in Ireland that have environmental product declarations. I'd like to see more. It's the ultimate in environmental labelling and transparency. And we can do it then to evaluate the embodied footprint of such buildings. Opportunities. I've been talking with Pat Barry of the Irish Green Building Council about having an EPD collective where we get the manufacturers together. A lot of them are represented today in the exhibits. And so anyone who's interested in promoting their environmental credentials, I'd urge you to get in touch with me or Pat, because we want to hear from you and hear what your needs are and why there might be a business case to disclose your environmental footprint. As I said, everything we do or make has a footprint, but only by disclosing it can we make improvements and strive for innovation. So Pat mentioned the home quality rating tool. We hope that this will involve some degree of life cycle assessment. And Lastly, we're considering having an EPD platform in Ireland for all products available and manufactured in Ireland. And I'm hoping that the Irish Green Building Council will host this. It seems a natural place for that. Lastly, looking to the future, building information modeling, BIM. This will allow you to do LCA in a few clicks. So we're saying that LCA is too complicated for us to handle, but you're already building models, 3D models on your computer. So once we upload the environmental product declarations, and there will probably be some generic values in there, certainly to begin with, it will get more accurate over time. So for those of you who have an environmental product declaration, how many of you are BIM ready? That'll be the next step. And lastly, if you have an environmental product declaration or you're building a building, procuring stuff, you get extra points for LCA and having EPDs through the various building assessment methods such as BREEAM, LEED, or even the Living Building Challenge. So bear that in mind too. There can be a benefit there. Get a higher BREEAM rating, be up to 10 points, and then get a better market value price for your building. I'd like to thank you all for your attention. It's nice to see my audience grew from 1 to 6 people. Is it? Brilliant. Thank you very much. I will take any questions gladly. If you want to go home, please do. Everyone's taken down already. You can download the report at that link. It's open source, so I urge anyone who's interested in this area to have a look at it. Okay? Thank you very much for your time.